A video about word problems involving systems of equations. Our first problem is about investing. Before we start, I want to point out the 5 steps to word problems. The first step is to create 2 let statements or define your variables. Then you're going to create 2 equations, solve for each variable, check each variable, and then answer the question posed in the word problem. Tran had $10,000 to invest. She invested part of it in a term deposit paying 4% per annum per year, and the remainder in bonds paying 5% per annum annually or per year. If the total interest after 1 year was $440, how much did she invest at each rate? So I'm going to define my variables as x and y. I'm going to let x represent or equal the amount invested at 4% per annum. And I'm going to use short form here. And I'm going to let y represent the amount invested at 5% per annum. My equations are found in my sentences. The first sentence says Tran had $10,000 to invest. And so we can conclude that if you add those 2 amounts together, you will get $10,000. The next piece of information is that she has part of it at 4 and the remainder at 5. And after 1 year, from those investments, she has $440. So be careful here because 4% turns into 0.04, not simply a 4. And 5% is the same. And that equals a total of $440. Here are my 2 equations. And now I need to decide how to solve for each variable. I can solve by elimination or substitution. Looking at equation 1, I think I'll choose substitution. It really doesn't matter in this case. So I'm going to put y to the other side. It becomes negative. And I'm going to multiply the bottom by 100, equation number 2. And that will allow me to deal with whole numbers, which is much easier. So that becomes 4x plus 5y equals 440, and then add my 2 zeros. I'm going to push number 1 into 2. So it becomes 4, not x, but what x equals, which is negative y plus 10,000. Continue on writing equation number 2. And now that I just have the one variable to solve for, I can go ahead and solve. I'm going to expand 4 into the bracket. Negative 4y plus 4, 0 with 3 more zeros plus 5y equals 4, 4 with 3 zeros. I'm going to collect like terms. This is a step you can skip if you can see the solution ahead of time. I like to show all the steps in my beginning examples, then I'll probably skip some as we go. So this becomes y equals 4,000. The nice thing about solving by substitution is you can use typically this equation now to solve for the other variable. So x is already isolated. Substitute in y, watching your signage, and you can see right away that x equals 6,000. So I've completed the first 3 steps of my 5 steps for word problems, and now I'm going to do my check. So I'm going to check 6,000, 4,000. I like to write my coordinate up top, and then remember that when you're checking the original equation. So it's x plus y, and the other side without the equal sign is 10,000, and then 0.04x plus 0.05y, and again without the equal sign you have the 440. Now let's sub in. So 6,000 plus 4,000. And I like to sub in on both sides before I start solving. And now 0.05 times 4,000. And now I'm going to add and multiply. So 6 plus 4, that is the 10,000 we were looking for. Both sides balanced. Left side does indeed equal the right side. Here, each one of these represents the amount of interest made. So at 4%, Tran made $240, and at 5%, she made $200. Add those together, and we have a total of 440. And now let's answer the question. So the actual question was, how much did she invest at each rate? Well, the answer would be, therefore, you can use 3 dots. Tran invested $6,000, I'll use short form, at 4% per annum, and $4,000 at 5% per annum. And that is word problem number 1. My second example is a mixing example. A chemistry teacher needed to make 10 liters of 42% sulfuric acid solution. The acid solutions available are 30% and 50% by volume. How many liters of each solution must be mixed to make the 42% solution? This is very much like the problem before it, with one additional task to do. So to create our let statement, it's fairly straight ahead. We don't know how much of 30% and we don't know how much of 50%. So we're going to let our x represent or equal the amount of 30% solution, and y the amount of 50% solution. Now, some people like this graphic that I'm about to show you, and some people find it confusing. So whichever person you are, use it or don't use it. I like to think of this problem as 3 buckets. You have 2 buckets being added together to create a third. Each bucket's got 2 parts to it. It's got the amount, and it's got the percentage of solution. So we have some 30% solution, and we have some 50% solution, and we're making 42% solution, and we have 10 liters of that. We have no clue how much of the 30% solution we need or the 50% solution we need. And I like this because visually then you can see your equations. So the x plus the y is going to equal 10. That's your total amount of liquid, of solution. And then the second equation will be, just like in the interest, you multiply those together, so the entire bucket together, to balance out your equation. So now our equations will be x plus y equals 10, that's the amount, and then 30% of x plus 50%, I did that wrong, I need to go back, just switch that out. So it's 50% of y equals, now be careful here, it's 42%, but you've already got the 10. The difference between this and an interest problem is that this value here in the interest problem that we just did is already calculated for you. That was that $440. In the mixing problem, it's separated out. So with our two equations, I can now solve. And again, I'm going to use substitution. So I'm going to say in equation number 1, x equals negative y plus 10. And in equation number 2, looking at it, I'm going to be really careful here. I'm going to show you that you have to be really careful with this value. So even though I want to multiply through to clear my fractions, I need to come up with that value first. I find if I take one more step here that I won't make a silly mistake. So multiplying through by 10, that will get me to 4.2. And now I'm going to realize that I need to multiply through by 10 again. And so I'm going to do that next, and that will give me 3x plus 5y equals 42. Okay, I'm going to take equation number 1 and place it into equation number 2. So that becomes 3. Instead of x, I'm writing negative y plus 10. Carrying on with my equation, and that equals 42. Again, expand, and I'm going to simplify. Negative 3y plus 30 plus 5y equals 42. Collect like terms. And again, if you can see the next step here, you can go ahead and skip this part. You're going to need to write this down, however. So this will be 12. And again, you can skip the divide both sides by 2 and get y equals 6. Solving by substitution allows you to very quickly find the second variable. So now we get x equals negative 6 plus 10, and x itself equals 4. I'm going to go ahead, I'm going a little bit quicker here. I'm going to go ahead and check both those. So it's 4 and 6 is my coordinate. So the POI, my x value is 4, my y value is 6. I need to check the originals without the equal sign. So that'll be x plus y on one side, 10 on the other. And then 0.30x plus 0.50y. And that equals 0.42 times 10. I like to sub into both equations before I go ahead and balance. So that'll be 4 plus 6. And on this side, 0.30 times 4. And the reason I use the 30 and the 50 is because it's 30% and 50%. It represents the words in the word problem. 0.3 and 0.5 are equivalent, but they don't match up with what the word problem is saying. So then it's 0.50 times 6. And at this point, I'm going to solve this side, so that becomes 4.2. And then back, so 4 plus 6 is indeed 10. Left side equals right side. This will become, sorry about that, this will become 1.2 plus 3.0, which is 4.2, and again, left side equals right side. Let's go back and figure out what the question is, and it's asking how many liters of each solution must be mixed, and your answer then is, therefore, you need 4 liters of 30% solution and 6 liters of 50% solution. And that is word problem number 2. And now we'll move on to distance problems. We'll do 2 different styles before the video is over. In the first style, a river boat took 2 hours to travel 24 kilometers down a river with the current and 3 hours to make the return trip against the current. Find the speed of the boat in still water and the speed of the current. So whether it's a boat or a plane, it's the same setup. let x represent or equal the speed of the boat in still water. This is important. The speed of the boat in still water. If it was a plane, it would be the speed of the plane in still air. And this is in kilometers per hour. And let y equal or represent the speed of the current. Hopefully you can read my printing, especially since I'm speaking the words as I go here. And now, I often will use a chart when it's a distance problem, and the chart is the concept of distance, which is rate times time, and that equals distance. In this case, we're going upstream and downstream. You could also say with the current and against the current. So the distance is the same. It's 24 kilometers. And it's saying that it took 2 hours one way and 3 hours the other. So this is distance, this is kilometers, this is time in hours. And your rate, of course, is kilometers per hour. Now, here, be a little bit careful. The speed of the boat is x. The speed of the current is y. So if you're going with the current, you are going faster, and therefore your time will be less. The current is helping you. So when you have a plus, that time is going to be less. When you're going against the current, it's going to take you a little more time, and so that should hook up to the 3 hours. So minus is the bigger one, plus is the smaller. And now you have your two equations. They're both going to be rate times time equals distance, rate times time equals distance. So straight across your chart, so it'll be x plus y times 2 equals 24, and x minus y times 3 equals 24. So x plus y in brackets times 2 equals 24. X minus y times 3 equals 24. And you can set this up the other way. I typically would actually. I would actually do it 2 times x plus y equals 24 and 3. But really this is potato. Depends on how your brain works and how you like to set things up. And now instinctively you're going to want to expand and simplify, and you can do that and it'll work beautifully. But I can tell you, if you look at these numbers here, you can also see that 2 and 3 both go into 24. So you can scale up an equation. You can also scale down an equation. So that's the solution I'm going to choose. So to show you, what I'm going to do is show a little bit more than I normally would. I'm going to divide both sides by 2. I would normally just do that in my head. The 2's will cancel out, and you'll be left with x plus y equals 12. And then the second equation, I'll put over here just for spacing on my screen here, will be the same thing. So it's x minus y times 3. Divide both sides by exactly the same value. And you will get x minus y equals 8. Put those together now, stack them, and you can use elimination or substitution. And you might think, because you have variables hanging out by themselves, there's no coefficient in front of anything, that substitution might be the way to go. I'm going to use elimination, and I'm simply going to add those together. I could subtract, it doesn't really matter. If I add them together, I'll clear the y's. If I subtract, I'll clear the x's. So I'm going to add, and I'm going to get 2x equals 20. Divide both sides by 2, and x equals 10. Doesn't matter which one I use. I'll use equation number 2 to find y. So 10 minus y equals 8. Negative y equals 8 minus 10. Negative y equals negative 2. And when you get to this point with a negative variable, you realize you can't solve for a negative variable. You can multiply both sides by negative 1, divide both sides by negative 1, or simply, as I do in my head, switch every sign and you get y equals 2. Now on to the check, and I will put the check here in the middle of our screen. So we're checking, make sure you write it correctly. X is 10, y is 2. The original equations, and it doesn't matter which ones we use, but I will use the first ones I wrote. So it is x plus y times 2, and that's 24, and x minus y times 3, and 24 on the other side. Again, I like to write in everything before I begin to solve. 10 plus 2 is 12, and that's 24. So on this one, the left side indeed equals the right side. This becomes 8 times 3, which is 24. And again, your left side equals your right side. Remember to answer the question that was asked. And the question that was asked was, find the speed of the boat in still water and the speed of the current. So therefore, the speed of the boat was 10 kilometers per hour, and the speed of the current was 2 kilometers per hour. And I forgot to write in the word boat, but here goes, boat goes right there. The speed of the boat was 10 kilometers per hour, and the speed of the current was 2. Last word problem of this video. This is another distance problem, and I'm going to read it this time and come up with the equations before I do the let statements. So I know that I have a chart, rate times time equals distance. I'm going to set up my grid because I know that I need 2 equations. And let's have a read. Nicholas drove 500 kilometers from Windsor to Peterborough in 5.5 hours. He drove part of the way at 100 kilometers per hour and the rest of the way at 80. How far did he travel at each speed? And this is one of those that you can set up in a variety of ways. So I know so far that my speeds are 100 kilometers per hour and 80 kilometers per hour. I don't know the distance at which I traveled at each speed, and I don't know the time that I traveled at each speed, but I do know, in this case, that the total time was 5.5 hours, and that the total distance was 500 kilometers. So I'm going to use that information and just augment my chart a little bit. So I know that my total time was 5.5 hours, and my total distance was 500 kilometers. And now I have to decide if I want my distance to be x and y, or my time to be x and y. If I let distance be x and y, then my time will be a fraction. It'll be x over 100 and y over 100. And I can deal with that, but I prefer not to. So I prefer to set up time as my unknown variable. So time is x and y, which will give me an equation of one time plus the other time equals my total time. So my first equation will be all about time. My other equation, though, needs to be based on the same information. So my distance is rate times time. So my distance is 100x and 80x. So in this way, I avoid fractions, and I can deal with finding the correct response to my question once I've done my check. So there are my two equations. X plus y equals 5.5. 100x plus 80x equals 500 kilometers. So in defining my variable now, x and y are time. So go back and start my process. So let x represent or equal the time spent at 100 kilometers per hour, and let y represent or equal the time spent at 80 kilometers per hour. So it's x plus y equals the 5.5, and then it's 100x plus 80y equals 500. Okay. Now you can scale up and scale down equations. And I could multiply my top by 2, and that would be probably the quickest way to get rid of my 5.5. But I'm going to multiply the top by 10, and I'm going to divide the bottom equation by 10. You can do anything you want as long as you're following the mathematical rules here. I'm looking at this, and just through experience, I feel this is the best way to go. Other people will feel differently, and your brain will, of course, tell you what will be easiest for you. So now divide by 10, I'm going to get 10x plus 8y equals 50. And that works out pretty well for me, because now I know that I can use elimination, by subtracting one for the other, and I'll get 2y equals 5, and y equals 2.5. And then I'm going to take that, and I think what I'll do is go back to my original first equation to solve for x. So it's x plus 2.5 equals 5.5, and hopefully you can see that x equals 3. So I made short work of finding my variables, and I'm going to check 3 and 2.5. So check 3 and 2.5. Original equations, x plus y, 5.5, 100x plus 80y, and 500. Sub in, being careful, so it's 3 plus 2.5, and it's 100 times 3 plus 80 times 2.5. And now I've got 5.5 on this side, so the first equation checks beautifully. The second one you might have to pull out your calculator, but 3 times 100 is 300. And 2.5 times 80, 2 times 80 is 160, half of 80 is 40, so there's our 200. And that indeed does equal 500. And this is the worst 5 ever. I'll just write that one more time. So left side does equal right side. So the last thing we need to do is write our therefore statement. And we have to look at the question again, because I didn't define my variables according to the question. I define my variables according to ease of finding what those would be. So how far did he travel at each speed? So where can I find that? Because it's not x and y. X and y are the time, but how far did I travel at each speed? Well, I traveled 300 kilometers at 100 kilometers per hour and 200 kilometers at 80 kilometers per hour. So you can find the answer to your question most often in your check. So therefore, what's the name of this person? Nicholas. So I'll just say he traveled. I never know if there's two L's or one L in the word traveled. 300 kilometers at 100 kilometers per hour and 200 kilometers at 80 kilometers per hour. And there we go. That's our last word problem. Thank you for listening.